Hi everybody. So using the example theta maps, this is a Greek letter called theta. We usually use it when we're thinking of an angle, but that's of course up to you. Using this map and the subset A, which is 0, 1, this is a notation that means all the numbers between 0 and 1. So you could say x such that 0 less than or equal to x, which is less than or equal to 1, but that's kind of long, and so people just write this, even though you might mistake this as a vector with 2 entries, but it's not. It's a subset of one-dimensional space of all the numbers between these two numbers. Okay, so using that example, explain the following. What's the image of a map? What's the image of a subset under the map? And where do they live? Okay, so part A. So the map, let's use the example. So here's the formula for the map. Cos theta, sine theta. So you should think circle when you see stuff like this, but let's see. The map sends the line to the plane. Line means the line means the space of real numbers, and the plane means R2, so tuples of 1, 2 real numbers. Okay, so it takes a one-dimensional thing and puts it into two-dimensional space. So let's look at a picture. So I'll do pictures in other colors. And so here we have the line. This is my picture of an infinite line. I cannot draw infinitely long, so I'll just do that. And I don't know, let's give this map a name. See, we didn't have a name up here, but we're just going to name it F. That's usually what we name things. And here's my picture of the plane, the infinite plane stretching forever and ever and ever and ever. But I'll just draw the beginnings of 2 axes. Okay, so what is this map? So in the input space, there's 0 and 1, and then there's all the numbers between 0 and 1, infinitely many. And where do they go? They go starting there, and then they stretch like that. And then they stop somewhere around here. This is a cartoon. Because this is 1 radian around a circle. You know, pi over 2 radians would be all the way to here, but this is only stopping at 1. So the outputs stop right here on a unit circle. I guess if we wanted to get really detailed, that's the point 1, 0, and this is the point cosine of 1, sine of 1, which doesn't have a nice expression. But actually, that's too much detail for me. I don't really care about that. If I went longer, if I went from 0 to pi over 2, then the image of that subset would be like that. And if I took the entire line, stretching forever and ever and ever, in both ways, the image would be around the entire circle, and then it would just keep wrapping around and around and around and around and around and around. It's getting thicker because I'm bad at drawing, but really, it's just that same circle again and again. It does not spiral in like I just did. It's just this circle. But since the inputs just keep going forever, we just keep wrapping around the circle. Okay. So I'll label that like this is the image of F, the map F. The entire image is the entire circle. But this part, this green part right there, that's the image of the interval 0, 1. We gave this the name A under F. So if we put the inputs only between 0 and 1, the only outputs we get are this little piece of the circle. Okay. And we'd call this image, it is written F applied to A. Okay. All right, and I guess, for the image of the entire map, we could say written f applied to, well, the entire input space. The entire input space. Okay. So let's just, that was sort of all pictures. Now let's do a little words explaining. Make sure we answer, what is the image? What is the image of a subset? Where do they live? So the image is all outputs when inputs range. They range in values. What can we plug in? They range in values over all possible inputs. That's the image of the map. Later, we're not going to use all possible inputs. We're going to use just the inputs of that subset. It lives, well, let's say the image of a subset. The image of a subset is what? Are the outputs. So the image of a subset are the outputs. The image is all the outputs. So these are outputs, but the inputs matter because now the image of a subset are the outputs when the inputs are restricted to that subset. Okay, in this case, here's the subset we chose. Okay, they both live in the output space. Okay. I think that completes part A. All right, part B. Let's see here. Okay, there's two sides to the coin. We have images and then we have preimages. These are also called contours or level sets. So part B, using the example of this formula, explain what is the preimage of a point, preimage of a point, okay? What is the contour of a map? What is the level set of a map? Do they live in input or output space? So you guessed it, part A, they lived in the output space. So part B, they're gonna live in the input space. So let's kind of start it the same way. The map, now I'll give back the formula that we're talking about here. It starts in R2 and sends it to a R. It takes a point, if we name it x comma y, then it takes it to what number? Well, this number, square x, square y, add them, and then subtract 1. That gives you a number. Okay, now the map, I'll say the map squishes all of the plane onto a tiny, tiny one-dimensional line. It takes a two-dimensional thing, the plane, onto a line. So it's going to squish a lot of things. And we're going to look at what are all the things that are squished to 0. Okay, so let's look at a picture. Okay, so we're always connecting words, pictures, and formulas. So let's draw a picture of this. The input space is my cartoon of the input space, and here's the output space. And let's just pick a point. 0 is 1 point. Well, let's pick another point. How about 3? Those are just 2 points. You're free to choose other points if you like. And maybe we'll label 3 with a different color, but first 0. Look at this. This is a circle of radius 1. So I'm going to say preimage of 0 is a circle of radius 1. And just in this example, this is an example of preimage. And then I'll explain it in a moment. So you might not understand what I'm doing at all, but that's okay, because this is how I'm teaching you it, just throwing you into it. Now 3 happens to be, because I've thought about this before, this circle. And what's this? This is, well, let's use a different word. Instead of preimage, let's use a different word, because some people say it. The contour of 3 is a circle of radius 2 in this case. Now, why is that? Well, because if you're on a circle of radius 2, the sum of squares is going to be 4. Subtract 1 gives you 3. Okay? Now let's think about this blue one again. A circle of radius 1, if you're on a circle of radius 1 somewhere, the sum of squares will be 1 squared, which is 1. We subtract 1 and we get 0. So you see that all the infinitely many points on this circle of radius 2 are all mapped to the 1.3, because this map squishes the plane onto the real line. And so a bunch of points are sent to 1 point. All the circle is sent to just the point 3. Okay, so maybe let's now explain in words. We have a good so the question we're answering here with preimages, contours, is what are all inputs sent to a given fixed output? Okay, and let's even make it more specific. Let's say sent to 0. That's an example. Well, we have a name for this. We call the answer to this question the preimage of 0. Or another way we call it is the 0 contour. Another thing we call it is the 0 level set. When things are important, they typically have many names. Even just in English, they have many names, not to mention other languages. But in English, these are 3 of the most common. Because this is really important. This is how we describe things by equations, like all the points where x squared plus y squared minus 1 equals 0. That equation defines this blue circle. Okay, anyway. We call the answer this. Okay, let me remind myself, what am I answering? What is the preimage of a pointer to the map? What is the contour of a map? What is the level set of a map? Yes, this is my answer. They're the answer to the question, what are all the inputs sent to 0, or sent to a given output? Okay, then, do they live in the input or output space? That's the last question up here. Oops. Do they live in the input or output space? So, they're inputs. What are all the inputs? Well, they live in the input space. That's it. So that was the second part. This is my full, complete answer. Yeah, I had words, pictures, and formulas. The first part, words, pictures, and formulas. And I was quizzing myself, so this is what you should do when you're studying. Open a blank sheet of paper, or, like this, and then go, okay, can I remember what's going on here? Can I say it in my own words? Draw my own pictures, could be different. Give the formulas. Well, the formulas are probably going to be whatever's written in the question. Can you do it? And I was practicing that, so here's my first answer. Let's look at that. Here's the first part. Here's the second part. Yeah, you see it's roughly similar. But you can do it in your own words, pictures, and formulas.